this is Robin. So today we will be discussing the question from GATE Physics 2023, and this is the question number 38, which is related to the concepts. So before I start the question, I would describe what are the concepts which it is related to. So quantum mechanics, harmonic oscillator, that's the part which is related to. So you should have the basic knowledge of the harmonic oscillator, the eigenstates and eigenvalues. And the next, it is statistical mechanics, canonical ensemble. So in that you should have the idea about what is the probability that it is found in this energy eigenstate, that how you calculate statistically, and the idea about the partition functions. So energy eigenvalues and the partition function. So let's start understanding the question and solve it. So the question says a simple harmonic oscillator with an angular frequency. So you are given the angular frequency omega, and this oscillator is in thermal equilibrium with a reservoir which is at the temperature T. Now you know clearly from this statement that you have to use the canonical ensemble because this is in thermal equilibrium with the reservoir at the temperature T. So that defines it is canonical ensemble. So now we have to find which is the correct partition function of the system. So let's start doing the question. So from this, the partition function is basically the sum over all the eigenstates. It's basically e to the power minus beta Hamiltonian, which is nothing but sum over all the eigenstates like this. Okay. Now, so you clearly see now what information you really need is the energy eigenvalues of the simple harmonic oscillator, which is h bar omega n plus half, where n goes from 0 to infinity, and so this is also going from 0 to infinity, and your beta is half 1 by kBT, Boltzmann constant under temperature. So let's just do this question now. So the partition function is nothing but you'll be writing n equal to 0 from infinity e to the power minus beta h bar omega n plus half. Okay, so let's just write it separately for all the states. So n0, it would be just this. So till infinity. Now you take, so this is nothing but the geometric series with a as e to the power minus bh bar by omega by 2 and common ratio as now, which implies your r is this. So your partition function is a by 1 by r. So e to the power minus beta h bar omega by 2, 1 minus e to the power beta h bar omega. Okay, now you can put the value of the omega which is given 2 kpt by h cut. So you put this and you get, now which you can write as 2 by h beta, right, because beta is 1 by kbt. So let's do that. Beta by 2 h bar 2 by h beta 1 minus, so these and these will cut, so you will get e to the power minus 1 minus e to the power this, so which is equal to e to the power square minus 1. now which is option E. So we have arrived at the correct option, which is option E. So this is the correct option. Thank you.